Good day, everyone. Good afternoon, good morning, good evening, depending on when you are watching this video. Yes, today we are beginning a new course. This is Circuit Space Engineering Services Project and Training Division. MMP on the driving seat as usual. Today we are going to start Lamborghini programming. We are going to discuss Lamborghini as a software package for industrial automation. In other videos, we have been able to discuss basics of Mitsubishi FX series under Melzek. Okay, with time we shall return to Mitsubishi when we shall deal with the higher versions of the programming softwares. But today we are introducing Lamborghini. Lamborghini is a brand under Rockwell Automation. Okay, based in the US. It's a very popular PLC, very popular, mostly used in oil industries. That's why we're going to take our time to deal with this, because it is used in most oil industries. Okay, so thank you, welcome, let's go there. Okay, now this is Lamborghini PLC. Here they are. This is Macrologics. This is 1000. This 1100. This is 880. This is 1400 and all that. But I'm looking at this Macrologics 1000. This very one. Okay, this 1000. So these are PLCs. All you do is to buy the PLC, make your connections, connect the input, your switches, your push button, your switches, your sensors, your flow sensors, temperature sensors, and limit switches, contact switches. Then the output is from here. Okay, so the input is from here, the output is from here. Okay, so this input output. So but the output is depending upon the nature of ladder logic written and downloaded into the PLC. Okay, beautiful. Okay, let's look at some connections. Let's look at how connections can be made. Okay, look at this. Look at this. Okay, now these are, you can see this is a stop button, that is NC. This is stop, that is NC. No, NC is stop. Okay, stop buttons are NC buttons, push buttons. These are not switches, they are push buttons. Switches are maintain contact. Push buttons are contact that return to its position after your hand is removed from mounting pressure on them. This is NO, which can serve as a start button. So you can see it's NO until I press before it can send any signal. Okay, now you can see the C is entering here, the B enters here, the A enters here. Okay, good. This is the neutral. This is the life. This is your power entering. Okay, whether it's 24 volt or life and neutral 230 volts. So this is your life and this is your neutral. The neutral is looped so that it will be common to everybody here. Then that neutral is also connected to here. Okay, good. Now this 24 volt is this 24 volt or 230 volt. It has to come. These are the load. These are okay. These are the output. This is our output. This is our input. This is our output. Now if I press C, okay, current will flow from here, pass through the C and enter into this terminal. Address is there has an address. Now once this terminal receives power, it will execute the program inside the PLC to know whether we are energizing blue or we are energizing yellow. You can see now. So this is neutral. This is neutral. You can see that life is coming to the load. This is load. This load is what we are trying to drive. But the way we are drive them and the way they are driven depends on the ladder logic program written and loaded inside the PLC. Hope you are following me. Here we have, if you power it, power will come on. If the PLC has program that is executing, you see run will be there. It has program written on it, you see run. When there is a fault, this fault will show. If you force any output without an input, this force will come on. For example, if I don't want to press this C, let's assume that this C, if I press it, this B will come on. If this C is bad, and I want to power this C, I will go to the software platform and force this input. I will force it on. This man will come on. Okay, that is so. At that point, this man comes on. This is a force. So when you force input, you don't want it to receive its feedback from the field. Probably the instrument is bad. You want to bypass the instrument, so you force the input to remain energized or to remain energized as per the condition. So here, blue and yellow are the outputs. You got it now? But they are the output of this output of the PLC are negative, because the positive is also coming this way to complete it. So when I switch, this man cannot come on until the program is executed. You get that? Okay. So it is this program that powers these outputs that is our business. To write this program, condition them, load them so that they can power, so that when we make any input, our output will be energized in accordance to our instruction. Beautiful. Okay, now look at this again. Look at this one. Okay, look at this one. Here you can see a switch. You know this switch now, this rocker switch. Look at it here. You can see live. This is a live and neutral. So this is DC. Okay, so this is your live. This is the common. The common is also taken to this place. Taken to this is CR. This is load. Okay, now this our live is also taken to this place. Okay, now watch. From here it flows to this place. You watch now. From here you can see it. From here it flows here. This to this, this to this, this to this. You can see now. So everybody here is under this man. Everybody here is under this man. So everybody here is under this man. Everyone is under this man. So everybody here is under this man. So here you have power coming in, but cannot go to this relay to complete the circuit. Get this negative until the program inside is executed. Only then can the program allow this link to be established. So a program is required called ladder logic or statement list or function block. But for the sake of our level of training and my business today and everything I'm going to do for now will be restricted to what? Ladder logic. Okay, ladder logic, which I discuss function block and statement list when it is time. Okay, good. So as well, you are understanding it now. You can see the switch. So if I switch this switch on now, this man will close. If this man close, this power that came from here will enter here. If it enters here, this is a relay. Look at the relay. You can see the relay. This is the base. This is a relay. So this relay has a coil. You can see it here, CR. That is this relay. So to power this relay, the program inside the PLC must activate, because this relay must function in accordance with the program written right inside the inside the PLC. Hope you are getting that. So this is I'm trying to make a explanation so you understand PLC in detail. If we on this switch, this coil will energize, but in accordance with the logic inside the PLC. Okay, but I may even call on it. It may not even energize if my logic did not ask this address to be energized. It will not energize. Everything depends on my logic. I hope it is understood. Okay, thank you very much. Now look at this. This is a wired PLC. You can see micrologis 1000. Okay, these are input I1, I0, I/0, I/1, I/2, I/3, I/4, I/5. These are inputs. Then these are outputs. Okay, these are outputs. So the input are DC voltage. Watch. Then the output is DC or relay output. Direct DC or a relay output. Then the powering of the PLC is using DC power. So you can see power, run, fault, and force. I have explained that. Is Allen Bradley. So this is the PLC inside the cabinet. But this output cannot work until there is a program written, and their working depends on the nature of the program. This is the cable. This is the communication cable or programming cable. Okay. Then these are the power supply. These are input terminals. These are output terminals. Then this is what we call the PLC. Okay, that is beautiful. So let's now go and simulate how it works. Let's look at some basic function. Okay, coming here. Okay, let's look at this. Look at this. Now, this 24 volt. This is a PLC. This is the card, input card. This is output card. Just like you saw here. This is input card. This is output. This is input. This is output. Okay. So in that same vein, I have this input output. So this is the ladder logic area, or the STL, or the function block. Now this is output. This output depends upon the program written here. Okay, it depends on the program written here. Okay, so now let's look at it. Now I have written the program. This is a motor in the field. Okay, this is C1, this is contactor, this is L1, L2, L3. Okay, now let's see how this system works. Now in my connection, I connected switch 1, one maintain switch, one NO switch, and one NC switch. This for starting, this for off. Okay, now this inputs we control the output depending upon the program I wrote inside this place. Okay, so good. Now I can, let me remove these guys. I can remove them. Okay, beautiful. I'm removing everybody here. Now let me write a program based on this input. So I will take a contact. I take a contact and pull here. Then that contact, I want to call it I want to name it IN1. That input 1. This is input 1. You can see input 1 is there. Okay, so I want to connect it. Then there should be a coil. Remember, in a distribution FS, there's always a contact and there's always a coil. Okay, so Okay, so let me put a coil. Okay, let me put a coil. So this coil, let me take it to output. Let me call it output 2. Output 2. I can choose any one I want. So I call it output 2. That is this man. It can be anything. I can choose any address to stay function. It's not according to how the thing is numbered. It's according to how the address is written in the PLC. Okay, so now I will connect the wire. Okay, good. So let's simulate it. You can see now we are simulating it now. Okay, let me power this man. You can see C1 has been powered. You can see the motor is running. C1 is powered, motor is running. You can see motor is running. Okay, so now you can see C1 is powered, beautiful. But I can use this same switch to power both the lamp, this LED lamp, and C1. So everything about this output depends on the program inside the PLC. Okay, let's look at this. Stop simulation. So now I want to add another coil. So this time this coil will be output 0. Output 0. Okay, then I want to connect it to this line. Okay, it's connected. Okay, so let's look at it with only one switch now. With only one switch now, I want to control 2 lamps. Because the relay 1, that is the contactor C1 and the LED lamp. Now let's see simulation. Okay, what you can see now, the 2. You can see now that what is happening at the output is according to the program inside the PLC. You can watch now. So I have two coils inside the PLC written. Now the same address I use in the PLC is the same address we are seeing in the output. You can see now. So that's what I'm saying. It doesn't matter. What matters is the program inside the PLC. Please, I want you to get that. What matters is the program inside the PLC. Okay? That is very important. Okay, now remember, see, this man is not doing anything because he's not nothing. They're not doing anything. They're not doing anything for me. Nothing for me because I did not use them. Okay, but now let me try using some of them. Now let me put kind of another contact here, switch. Then let me call this man IN2. IN2. Let me call it IN2. Okay, that is input 2. So this man now is owned by this man now, input 2. So I can connect it. Now it's connected. So I can also use this man. Okay, I can remove this man. I can put this another switch here. Okay, this man will be IN3. I enter that off. I enter into 3. Beautiful. So I can now extend this. They are connected. Okay, so I simulate. Now look at it. You look at it. So now I start with this. You see, I'm starting from input 2. And everything is working, but if I release it, it will go off. The reason is that it is a push button. if I want this man to hold, I have to lash it. Remember the way we normally do lashing in Mitsubishi FX. Look at it, it cannot hold, but it's working. But this is maintain switch, it will hold. You see, now if I want to do like, if I want to make it hold, while on this, the only thing I will do is I put another contact, okay. Then this contact, I will call it, I'm going to call it, I will use this motto, that is C1 output 2. Let me give it to output 2. So once output 2 energizes, okay, good. So once output 2 energizes, this man energizes. Okay, let's see. So I don't need to hold it again at this time around. Now watch simulation. Watch, if I press input 2, it will latch. If I remove my hand, the output 1 and output 0 and 2 will continue to function, unlike before. Now watch. You see, I've removed my hand. You see, you can hear me clapping. The reason is that I have latched it using the contact of what, the T2. Okay, T2 pushes the coil. So this is what you obtain. Okay, this is your input switches. Okay, this is your input, your PLC card, Q card, this is output card. This is the PLC. Go. Everything that goes to the output depends upon what is written in the PLC. Okay, that being said, let's look at some few things here. Okay, now this Alhambra window, I hope you have this. Okay, you got this. Okay, so now let me take a new project. Taking a new project. Okay, I will take Alhambra Micrologics 1000. Okay, say okay. Now, so this is now here I will discuss this, everything about this in my next video. Okay, in my next video, but I just want to show you what I have done here. What I have just done here, I want to show you in the Alhambra environment, because this is not Alhambra, this is Automation Studio, which helps us in teaching automation engineering. Okay, that is beautiful. Let me remove the simulation. Okay, good. That is beautiful. So now, if I want to write the same program here, remember I'm going to explain everything. If I want to write the same program here, what I do is, okay, but let me just give you the basics. Okay, this is online download, upload. Okay, now here is your instruction sets. Okay, this is instruction sets. This for neuron, this is branch. Okay, this is your basic input. This is output coil, latch and unlatch. Then we'll have other ones, timer and counters. Okay, input output. We'll have compare, limit, mask equal, not equal, less than, greater than, less or equal to, greater or equal to. All those things are here. We have add, subtract, multiply, division, and all that. Okay, we have and, or, no, not, all those we have them. Okay, we have other like a scale. Okay, and you have scale. We have interrupt subroutine. We have STI enable, have STI set immediately. We have STI disable. Okay, we have file copy. All these things and many more are what we are going to be using to present our program. So, but now I'm returning back to the basic instruction set, which is this. So now, first of all, you click on this red patch. If you click here, then this one turns gray. That means you are ready. If you look at this place, you have your business here is today's your main program window. Ladder logic 2, that's like 2. That is the main program window. You have like 3, like 4, like 5. Then from like 6 to like 15 is available for you as a subroutine. All that we see. This is our program instructions. Okay, the output, input, status, binary, timer, counter, control, and all that. Okay, so let's look at what we wrote before. Let us practice. Let's look at this. How one achieve this. Okay, so we'll see this way. Then I will take. Okay, let me add a wrong. Okay, I've added a wrong. Good. So I take one NO. So I need an address. There is always an address. Remember that we see in this place. Here you saw I/0. That's an address. I/1 is an address. So this address cannot exist. Cannot be 2. It's always 1. Okay. Now here I will have. Okay. So now we want to write a basic logic program. Okay, now let me take this is examine if there is NO. Just once the green show, drop it. Then you click on the question mark. Click on the question mark, then put your address. Address is in this form. I is input. Then column 0. That is rack 0. Then slash the input go 0. There is always 8 bits, 0 to 8. So I can use column 0 to 7. Then column 1 0 to 7. So each of them has 8 bits of signals that can come through them. So now I can enter. I'll say this one is on. Already the name is on. Okay, then I click OK. Now what will energize? This is a coil. I take this coil, I'm going this way. Remember, it's a coil. Now I have green, I release it. Coil is an output. So in the Lamborghini, output is O. That is O, not 0 O. In Siemens, it is Q. Then column 0/0. Okay, that is on the output side. This is output, this is input. Okay, this is output, this is input. So I enter. Okay, this is let me call this output 1. I see output 1. Okay, look at this. If you look at this place, now I use this to do what? To power this man. Okay, so let me now look this one. Now I can compile this. Say I need to know whether this program is right or wrong. To know if it is right or wrong, I need to compile it. There's an error it will show here. Now this, look at this. This is a verify. Let me verify it. You can see, watch here. Verify has completed. No error found. Then compile project. Verify project. It has verified, no error found. So as it is now, the next thing I can do is to download it to the PLC. Say I need to save it. Okay, I will save it as let me call it anything I want. Circuit. I'll call it circuit space 1 2 3. Okay, that is the name. Then I save. Okay, he said, are you sure you want to proceed with the download? Yes. Want to go online? Yes. Can you see now I'm online? This can see that this ladder is turning, so I am online. Then the next thing is what? I will run the PLC. Should you want to run the PLC? Yes. Now you can see there is power here and there is return power here. Now the next thing is to turn this man on, and this man will come on. Okay, so I will toggle the beat. Toggle beat is is a push button. Okay, is a switch like this. Is a switch. Okay, is a switch like this. Okay, like this switch. Okay, so let me do this. I will toggle beat. Can you see it is on? Okay, it's on. Okay, so but if it is a push button, I will toggle the beat again. It's gone because there is no lashing. It was not lashed. Okay, so if I want to, I can lash it. I will now say, I will say, I will go offline. I will go offline. So here in the offline, I want to lash it. I want to lash it. What I will do is I will take a branch. Watch. I want to lash now. I'm writing basic program. I take a branch. Okay. I put it here. The green is there. Oh, sorry, that is not a branch. This is a branch here. As a branch. Then I'll drag this man inside it. Drag it inside until the inside the square shows green. I draw. Then I take an NO, drop inside. Give it at the same address with this. This address here. Okay, this very address here. I can drop it. You can see the way I carried it. You can see the way I carry it. I just pick the address. I don't know the type. I just put my this thing here. Okay, and I carried the address. I carried the address and I drop it here. So now, if I verify, no error, verify project, no error, then the next thing I do is I download the program. Okay, still the same old circuit space 1, 2, 3. Now I run the program. Yes, the power is here and the return is here. Now if I toggle bit and then I remove it, you can see. Why is this still on? Because that is the lashing. The lashing is there. Okay, so thank you very much. This is just introduction into Lamborghini Plc. I started from the grassroots, showing you the PLC, the mode of the build up from this automation studio. Then from there I came into the PLC. I also showed you the physical PLC here, okay, to see where it's wired and things like that. I hope it's a beautiful one. Please remember, we are in what? Circuit space industrial circuit engineering training. Circuit space engineering training. MMP in the driving seat. Thank you very much. From here we'll go into program writing all the way. No more moving from here and there. Now I hope you've understood everything that is surrounding this PLC. Hope you have understood it. Thank you very much. God bless you.